Okay, this week we're going to be talking about some basic information about polynomials. So a quick definition of polynomials. Polynomials, an expression containing variables and coefficients that only involve addition, subtraction, and multiplication, and here's one important part, and only positive whole number exponents. So now we're going to take a look at a couple different expressions and determine whether these functions are or are not polynomials. Let's take a look at the first one. Well, when I look at square root of 4x, you may know this, you may not know this, but square root can be written as an exponent. That would be x to the 1/2. We can see that this is not a positive whole number exponent, so we're going to determine that no, this is not a polynomial. Why? Because it has fractional exponents. The next one we take a look, it's x squared minus 5x plus 3. We can see that these are all, this is a positive whole number exponent. This is x to the first power. This doesn't have an exponent on it, but there's no fractions or anything like that. So we're going to say that yes, this is a polynomial. It says if it is a polynomial, identify the degree. Well, the degree is just the highest variable term, any of these. These are actually monomial terms. Something that just has one term, something like y is equal to 2x, that would be a monomial. So these different monomials, which one has the highest exponent? Well, it's the squared term. So this would have a degree of 2. The next thing we're looking for is the leading term. And the leading term is this whole term that is attached to the highest degree. So the leading term would be x squared. The leading coefficient is the number attached to the leading term, the coefficient attached. Well, we know there's a 1 in front of that, so the leading coefficient here would be 1. And finally, the constant term is the one that does not have a variable, or there's not always a constant term, but since this doesn't have a variable attached to it, the constant term is 3. So we know that this is constant because regardless of what I plug in for x, I'm always going to have that 3 in there. That is not affected by whatever the x value is. All right, let's take a look at this next one. X squared plus 2 divided by x minus 1. You can see that this has division in it. Division is not allowed in the, it's only, a polynomial only involves addition, subtraction, and multiplication. So this is not a polynomial. This is actually called a rational expression. Finally, the last one we're going to take a look at, 1/5 x to the 6 minus 6 over 13. Even though this has fractions, the exponent on this term is a whole number. It also only has addition, subtraction, and multiplication, because you can see that there are multiplication between these coefficients and these variable terms. So this one is going to be yes, it is a polynomial. Let's determine the degree of this polynomial. See if you can figure this out. Well, the degree is going to be the highest power, and the only power here is 6. So this would be, the degree of this polynomial would be 6. The leading term is this whole term out in front, which would be 1/5. So leading term is 1/5 x to the 6th. Leading coefficient would be the 1/6. And finally, the constant term would be this term right here, which is negative 6 over 13. All right, let's take a look at a couple graphs and see if we can figure out which one of these graphs is a polynomial. Whoops, I messed up. I recorded this video once before and I didn't have the sound on, and I guess I forgot to erase this. This one right here is not a polynomial, and the reason we know that this is not a polynomial is because a polynomial graph needs to be continuous, and we can see that we do have what looks to be a parabola right here, but then there's this break in the graph right here. This is a discontinuity. Since we have this break in the graph, we know that this is not a polynomial. This graph, on the other hand, you can see has a nice continuous shape. You can see it's smooth, it has these x-intercepts, which we'll talk about in the next video, and it follows a nice, smooth, continuous path. This would be the graph of a polynomial. In the next video, we're going to take a look at some special characteristics of polynomials.